Welcome to HVAC and Controls, the Core Knowledge Series. This first topic will be our beginning topic, Environment, Systems, and Controls, and Introduction. I'm Norm Christopherson. I will be your presenter for this series. Just to let you know who I am, a little bit of my background. I have over 50 years of experience in HVAC and controls, and I worked as a mechanic, a controls technician, and as a teacher. I have degrees in electromechanical technology, HVAC technology, then went on and got a bachelor's in liberal arts and a master's in educational technology. It is my objective to simplify this material as much as possible, but not any simpler. But let's go ahead and get started. First of all, the objectives that we have here is to identify the key elements of an HVAC system. We're going to be talking mechanical, and then we're going to be adding controls to it later. My core audience is going to be HVAC mechanics, controls technicians, sales reps, and building owners, and of course, the curious. If you simply want a review of what you should already know as a mechanic or as a controls technician, this is the place to be. If you're just starting out in the industry, this is the place to be. So this is a core knowledge series, and that's what we mean when we say core, the fundamentals. There are three key elements of an HVAC system. Notice the building in the center of our diagram here. We have an environment in that building. We're trying to maintain the conditions in that building. If it's for people, it's for comfort, that we're trying to control the conditions on, or if it is for some kind of an industrial process or computer room, we want to maintain the right temperature, the right humidity, the right airflow, and we want it to be clean air as well. It's going to take equipment to do that. That's the system circle. I know they didn't put in the system circle picture the mechanical equipment that I wish they had. They put a solar panel in there, but I mean by boilers and chillers and pumps and fans and ductwork, equipment that is used to match the conditions we're trying to maintain in the environment, the right temperature and humidity and those kinds of things. Then on the right, we have the control circle. And so in the control circle, we would have what we really spend a great deal of time with in this course is controlling the equipment in the system circle in order to meet the needs of the environment circle. When we're talking about the environment, as I already mentioned, we're talking about maintaining the temperature. We're talking about maintaining the right humidity, the air movement, and of course the air purity. If you want to pause any of these slides and read them, I won't read slides to you, but you may pause and take a look at what is in the text. Temperature first. So temperature, it says, is a measure of the intensity of molecular movement of a substance. You know, I have a collection of dictionaries at home, and I look up the word temperature in the dictionary, and it has a definition that is not very helpful at all. It says temperature, the degree of hotness or coldness. Now that really isn't of much value. Let me give you an explanation that is going to be of much more use as we progress through the series. You know, we're told that everything that is around us is made up of atoms. If you look at an atom closely, if you could, it has a nucleus, a center, and then in orbit around the outside of that atom are electrons. And so if you think about this, you know there's energy present because there's motion orbiting electrons. If we were to back up even farther so we could see 3 or 4 atoms, we would notice that not only did we have the orbiting electrons, but we also have the atoms themselves vibrating, kind of vibrating in place, you might say. Temperature is the speed of the vibration of those atoms. Now, chemists sometimes combine atoms in a molecular bond, and we'll get atoms of 2 different substances. For example, iron atoms and then carbon atoms could be joined together and you get steel. Well, the molecule that is formed, the molecule that makes up steel, for example, is like a solid unit, but it itself will vibrate. The speed of the vibration of both atoms and molecules is what makes up temperature. This is going to be of use to us as we explain some more concepts involved in HVAC later in the future. Hearing people say, well, it's not the temperature, it's not the heat, it's the humidity. Obviously, we want to control the humidity in a building. We'll move on. Air movement is necessary in a building. In fact, we probably not only want to control the air movement, but we also want to bring in a certain amount of fresh air from outside. We want to take and control our air purity. So we're going to talk air filters at some time in another presentation. Then we have the system circle. That's where we have cooling systems, heating systems, air distribution and water distribution systems, terminal units, and then we have special up there. Let's take a quick look at each one of these items that's in the system circle. First of all, we need a cooling system, and that would be compressors and condensers and evaporators and refrigerant and piping. The refrigerant cycle, chillers come into mind here. Also need some heating, so they're showing us some boilers here where we might take and heat hot water or even create steam. Either the air or the water, whether it be hot water or chilled water or air, we need to distribute it through the building. So for air, we would distribute it through ductwork, and for water and steam, it would be through piping. To the room where we need to inject the heating or cooling capacity into the space, we are going to have what we call terminal units, and we'll look at those in more detail. And then the folks who made these slides for me just said, well, if there's anything else we're missing, the term special. So we'll kind of leave it at that. Now, controls are going to fall into three parts. Every single control system is going to have a sensor, a controller, and a control device. Let's briefly talk about each one of these, and we will spend quite a bit of time in future videos on each one of these and then put it all together. So this is our first look at sensor. The sensor sits in a room or a space and measures the conditions that you have currently. For example, a temperature sensor would be in a room on the wall, and it would measure the temperature, and it would change that temperature into a signal that can be understood by a controller. More on that later. The sensor is going to take and send a signal that represents temperature, humidity, or whatever it is we're measuring, and it's going to send it to a controller. Controller is going to have the set point in it, the desired value, the value you want to maintain. So for example, if we want to maintain 70 degrees Fahrenheit in a room, we'll put the 70 degrees Fahrenheit in the controller. The sensor, on the other hand, is actually sending to the controller what the temperature actually is in the room. If the sensor sees it 70 degrees, sends it to the controller, and the controller compares it to the set point of 70 degrees, the controller doesn't have a job to do. However, if the sensor senses the temperature 75 degrees, sends it to the controller, and the controller says, well, it's supposed to be 70, then there's 5 degrees of error. Did you catch that? Error, the difference between what you measured at the sensor and what you want as a set point at the controller. If there's error, the temperature's too warm in this case, a signal would be sent out to a control device. Control device is the third part of our control system. Notice we have a valve here, and the valve has a motor on it. We're going to separate those two items as separate pieces of equipment. The valve is the control device. The motor is going to be called an actuator. If the controller notices that the temperature is higher at the sensor than what the set point calls for, the controller will send an output signal to the control device, in this case opening a valve and maybe bringing more chilled water into a coil. There you have it, sensors, controllers, and control devices. Well, here we have our building again with the environment we're going to control with equipment in the system circle, heating and air conditioning equipment, and then the control circle on the right. But we're really in the building automation and controls business. And so notice that the building environments are HVAC, life safety, security, sound, and lighting. Briefly, let's take a look at those. We've talked about HVAC, where we have a sensor on the wall like a thermostat, which is an input to a controller, and the controller has an output to, let's say, a valve or a damper or some device in the mechanical system of the HVAC system. However, life safety also has an environment, a system, and controls. For example, in life safety, the sensor might be a smoke detector, which is an input to a fire panel. There's your controller. And then that controller from the fire panel has an output to maybe lights and a siren, or maybe even to have an output to call the fire department. The security system. Someone swipes a badge at the front door. There's your sensor. It sends a signal to a controller in the building, which then compares the code on the badge to the code that has been programmed into the controller. And if it is the right code, it's the right person at the door, an output goes out to unlock the lock, which would be the control device. How about sound? Someone standing at a microphone in front of an audience. That microphone is the sensor. The sensor sends an output to the controller, and the controller raises the volume and then sends that signal to speakers, and the speakers are the controlled devices. And of course, lighting, we might have a sensor outside the building, and when the sun goes down, that sensor sends a signal to a controller, and the controller then sends an output to turn the parking lot lights on. We're looking at building automation and control systems that all have sensors, controllers, and control devices. If you keep those three in mind, you're well on your way to understanding control systems. So thanks for watching, and we'll see you next time.